Hello guys, in this tutorial we are going to discuss about the AIOS metric system and especially how to access the live metrics and how to leverage them for monitoring, debugging and any other policies like autoscaler kind of policies. So brief overview is we will be seeing some of the metrics like the resource utilization, uptime and all to understand to monitor the block's health and to analyze the performance, right? Like the inference latency and the throughput, like in the case of LLM scenarios, tokens per second and other performance related metrics. And also there can be metrics related to identifying any bottlenecks like the queue length of last 15 minutes, things like that. And also these we will also see like with a sample example like how to use in some of these metrics in the which metrics can be used in the autoscaler policies as well, right? So basically we will cover how to access the block metrics, and we will understand the different fields in the JSON of the metrics that we are getting, and we will interpret the metrics, what the metrics are, what they are conveying and all, and also we'll just visualize metrics with the JSON data. And towards the end, we will also give a comprehensive overview of the how to integrate your own custom metrics to the blocks, right? So let's get started. Okay, now first we will see how to access the block metrics. So the primary way, so before that, if you guys want to get more detailed overview, I would highly recommend you guys to check this link. It has a detailed discussion about the different kinds of metrics and where it will come in the overall AIOS ecosystem, and it also explains each of the fields present in the JSON data like CPU, memory, and all. It contains each of these data and how to access this data with curl request and all. And we have different functions that are there in the inference code of the models, and how to get those FPS details are also available here, right? So to access the block metrics, first of all, we need to use the metrics API from the AIOS ecosystem. So the metrics API goes like this. So the service API will be present here, its port, and block is the endpoint that says we need the blocks metrics, and we need to pass the block ID as well. So here, for example, I'm passing this particular block ID, Magistral small 2506 Llama CPP block, and if you run this, basically I'm just getting via the curl request. If I run this, I will get the live metrics now. Yeah, so here you can see, so here you can see we have just received that live metrics, right? So let me open it in the browser so that we can see it easily. Let's rerun it. Yeah, I think, yeah, you guys can see, right? So the block ID is Magistral, and we have all the metrics under it, right? So what is the structure and what kind of metrics are present? We will go through it now. Okay. So in this whole JSON, there are mainly, primarily there are three key fields. So the first is the data field. So this is the root object containing the array of metrics, right? So you can see it here. This is data field, right? So it's an array. It contains an array of block IDs like this, right? And each block ID, then it has its own instances also. So for example, so here, yeah, and of course, we also have the key block ID to say which particular block this particular matrix belongs to, and then we have the instances, which contains the array of metric objects. The metrics for each of the running model, right? So let me show that here. Yeah, so under instances, so we have the executor is also an instance. That's why it comes here. But apart from that, the actual LLM model also is an instance, which you can see it here. The instance ID is available here. In SX7P is the instance ID, and all the metrics are available within that as well, right? So broadly, we can categorize this metrics into four types, right? Four hierarchies. So one is the system metrics, which contains the uptime and uptime hours and uptime minutes and all. And also the hardware metrics, which is nothing but the CPU, GPU, memory, RAM related metrics. Then if we have implemented our custom metrics for the model, like the LLM specific metrics, so those things also will be available, like metrics like LLM tokens per second, LLM time to first tokens, token seconds sum, just nothing but the sum of all the first tokens, and then LLM prompt tokens total, the total tokens generated by the LLM model. And also everywhere we will see something called a rolling average, which is nothing but it is we have a time series DB. All these metrics are monitored via time series DB, and there we have we'll monitor over a 1 minute period, 5 minute period, and 15-minute period. So in case of using the metrics for any actual actions, right, like autoscaler or any load balancing kind of actions, we can use either 1 minute or probably 15-minute kind of averages to avoid spike based decision making, right? So that's the purpose of rolling averages. And also in general, we want to know an average metrics, right? Not just the instantaneous or spike spontaneous data. So that's why we also have a provision where you just have to register the metric name. Then internally the AIOS will take care of calculating the rolling averages for you. Okay, now let's move on to understanding some of the key metrics in this. Actually, there are so many. We have defined many custom metrics here. I'll just give a high-level overview of some of the metrics. So here, the first metrics and the most common one is the LLM tokens per second. So let me show that here. So here you can see that the LLM model is generating tokens at 44 tokens per second. So what it means is we understand that all these LLM kind of models, they work in terms of tokens, right? So we want to know how fast the LLM can generate the response for us. So that is usually measured by tokens per second. And higher tokens per second means the model can process and generate responses faster. So that's why we are monitoring this. And similarly, we also have LLM time to first token seconds sum. So we have sum because we can calculate the first token seconds across different requests and then average it out based on the total request. We also have the time to first token also, right? So here you can see the LLM TTFT rolling is nothing but time to first token. So what is first token? The first token is the time it takes by the LLM to generate the first text, right? First token. Let's say in UI, the time it takes to receive the first string or first word from the LLM, right? So that is the meaning of time to first token. And we are also considering, as a kind of a histogram, we have a bucket count and sum also, so that we can get more insights if required. And similarly, we have LLM active sessions. Active session is nothing but the number of users currently using the performing inference or currently using the model, right? So that's a good indication to say what is the load in general, right? So the difference between, let's say, a 10 active session and 100,000 or 1,000 active session is so huge, right? So that is also one of the important metrics to watch out for. So that also we have it here. LLM active sessions. Currently it is 0. If I do inference, it will be there. Similarly, hardware.gpus.utilization. So what's the, let me show it here. So we have this hardware metrics. So it for CPU, it contains the load average of 15 minutes, 1 minute, and 5 minute, and also a percentage number. And also for GPUs, we have the what is the free memory, what is the power utilization, the total memory and all, right? And what is the used memory. And this is true for each of the GPU. So for example, in the machine where I'm running this magistral model, there are 2 GPUs. That's why you are seeing ID0 and ID1 here, right? So that is one thing. And similarly, the memory. So what is the memory, that is in general available across the these kind of GPU and CPU hardwares. And you also have the registered CPU utilization rolling. The rolling things will come back. Similarly, GPU utilization rolling. And we also have the memory usage, the CPU memory usage in bytes also, right? So that is also another interesting metric to watch out for. So how it helps us is, let's say if the particular GPU or CPU load reaches 100% or 95%, then it says there is we cannot run any more inferences on that, or we cannot add a new users to that particular model, right? So that's the purpose of using these metrics. And similarly, the average utilization, which is nothing but the 1 minute, 15 minute, 5 minute averages that I was mentioning about. And we also have end-to-end latency. And end-to-end, what is the end-to-end latency? It basically measures the total time when a request is sent to when the final response is received, right? So like given a request, what is the total time it takes for me to get the final response? That is the end-to-end latency. So that is also available as part of the metrics, right? So now I will go in detail more next, but let me just show you some basic plots to understand what kind of data we are getting here. So basically I'm just plotting, I'm fetching the data. So we have stored the data in the metrics data variable, right? Now I'm just accessing it and plotting it to get an idea, to what kind of metrics we'll be getting, like a visual representation. Yeah, here you can see the x-axis contains the executor and the instance ID. If there are many instances or other instances, right, so that will also come in the x-axis. And similarly, in the y-axis, the tokens per second is there for LLM throughput. The GPU utilization, the corresponding utilization is there. Similarly, in memory utilization and CPU utilization. Right. So with more and more instances, this graphs will help us in understanding, visually how the metrics and how the load is there in the machine. So now let's move on to understanding how to create our own custom metrics and how to register these metrics as part of the AIOS metrics flow as well. Right. So first of all, we need to understand, we can actually integrate our own custom metrics to this block in the AIOS ecosystem. So for that, we need to understand certain things. So the first thing is we need to understand what are all the default metrics available in the AIOS ecosystem itself. So the SDK that we use, right, the AIOS instance SDK, it has the some of the core functionality for registering and collecting metrics. It's already built in. So it is implemented under the class AIOS Metrics, and which basically takes care of registering via the Prometheus metrics, and it also has a facility to register any metric as a rolling metric. And so it can be, since it is available in AIOS instance SDK, it can be used for any kind of computations. It's not necessarily LLM or deep learning model or anything like that. It can be used in general for any kind of computations. And now if we have some metrics specific to a LLM model, so for example, in the AIOS Llama CPP SDK, there we have some other metrics that we have implemented, which are nothing but metrics related to the LLMs. So it is like extending this base AIOS instance SDK, extending that functionality with this particular AIOS Llama CPP SDK, right? So here we have this class called LLM metrics, where we can again it will basically use the AIOS instance SDK's AIOS metrics to register and collect the metrics, right? So just to recap, we have two metrics. One is the AIOS instance level metrics, and another is the particular framework like Llama CPP framework level metrics, right? As a general thumb rule, if you want to register any metric, first understand what is the metric that you want, right? Let's say you want to track a user satisfaction score, right? So like that, you have to define your metric first. And then in your block code, which we will see in some time, you will have something called observe custom rolling and all as part of the AIOS metrics instance. So there we have to use these functions to register the rolling average metric. And how the registrations happened is like this. In the observe rolling, we call this metric name and we'll pass the value. I will show a quick example also. And you can also see that once you register these kind of metrics, in the final JSON that you see, if you are using a rolling average, you will see 1 minute, 5 minute, 15 minute averages and all. So we also have provided metrics updated.py as part of this notebook. That will be a good starting point for you guys to understand how the LLM metrics is implemented and how it is extending the AIOS metrics also, right? So I think with this in mind, let's move on to sample a quick implementation. So here, before that, let's not forget the role of rolling metrics. They are very pivotal, and the main reason for using it is to smoothen the metrics, and smoothen helps us in avoiding the short-term spikes and dips and all, providing a more stable and representative view of the block's performance over time. And also to understand the trend in case of gradually increasing load or things like that, we can have some kind of monitoring mechanisms to understand how this this trend is happening. Similarly, let's say we are registering metric related to something like a tokens per second or the number of sessions and all. So we can use those kind of metrics to perform autoscaling based on that, right? So that's the purpose of and the beauty of rolling metrics, right? So here we have a quick small implementation. So this is just a conceptual example, not necessarily for you to take it and use it. We have given other documentations as I have mentioned here at the top right. So you can refer these documentations to see how to extend these or implement these metrics in your own block code. So here, so you will see something like this, right? In the rolling, we will have a class called rolling metric in our AIOS instance SDK. And similarly, you will have something called AIOS metrics also. And the AIOS metrics will use this rolling metric to register and to do all kinds of stuff. Like for any metric, it can perform a rolling metric, right? So how we will use it in our block code is we'll have our custom implementation, and we have to, this AIOS metrics will come, it will be extending this class, right? Our metrics block will be extending this class. It will be available as part of the context in the block code, which we will see also. And let's say we are defining two of our custom metrics. One is log user feedback and another is log cache hit ratio. Log user feedback is just a satisfaction score if the user is giving some feedback. Log cache hit ratio is another generic, if the tokens are cached and we are using the cache and all, so that also can be used as a metric. So here you can see I am calling my block metrics, initializing my block metrics with the AIOS metrics backend, right? So which is what I'm passing here. And then I'm calling my block metrics, and using the methods, I'm creating the, registering the metrics. So that's what is happening here. Similarly, you can see for each of the metrics I'm doing this, for each of the metric I'm doing this. Similarly, rolling metrics also I'm registering like this, right? Once it is registered, it will start giving the rolling averages. A quick run here. Yeah, so these are some of the hard-coded values, but This is just a quick sample. Okay, now I will show you how to actually use these metrics in our block codes, right? So first of all, if you have seen the main.py kind of codes that we usually use to to do inference of the model, so they will have something called the init method. So in the init method, we will receive something called context as part of the its arguments, and that context will contain the AIOS excuse me, that context will contain the AIOS instances actual metrics handle. So that's why we use the context here, and then we will use that context, and then we will pass this context to our custom metrics. So here we are implementing our custom metrics, right? My block metrics, right? So once we have our custom metrics in place, so in this case, in this file that I have created, the file is metrics updated.py. I have created a class LLM metrics updated, right? And so here I will pass that particular AIOS instances metrics handle. So it will use that to register its own some of our custom metrics, which also I'll show. So after this, we also have in the library code that we share as part of the SDK, we have something called llama utils. So we will simply mention what is the metric that we are actually gonna use. We can have multiple versions of our metrics, right? So we'll pass the final metrics that is instantiated here to this particular llama utils class also. So that, right, internally within the llama utils definition and all, we will correspondingly adjust the streaming metrics. So for example, if it is just a block metric and we don't want, let's say it's just an inference and without streaming, so maybe the time to first token calculation there it is different. But if you are using a streaming kind of model streaming also, there the time to first token will be a bit different. So for things like that and for many other customizations, we are passing this metrics also as part of the llama utils. So the llama utils nothing but some of the utilities like the chat interface, the completion or generation interface for the LLM models, right? So here, so one sample custom policy that custom function that we have is log prompt. So what we do is during the first whenever we get prompt, right, we will whenever we get actually the message from the natural language message from the user, we will calculate the total prompts. We can have something called input prompts also, we can have output prompts also. I think here it's the output prompts. So here you can see that what I'm doing is I'm doing something called self.metrics.increment counter. This increment counter and the self.metrics are nothing but they are part of the AIOS instance SDK's methods. And there I'm using the string the LLM prompts total, so it will increment its counter. So similarly, we have something called LLM prompts token total. So that is just a counter, right? So what I'm doing is I'm also incrementing that counter with the actual prompt token count, right? So let's say the model is giving 50 tokens, so it will be incremented by this particular field will be incremented by 50 values. So if you want to observe the rolling average, right, the LLM input tokens per minute rolling. So that means like let me show you here itself. Yeah, here you can see what is the average 15 minutes data, or average 1 minute data, average 5 minutes data, right? So that is the purpose of this particular metric. So this is how we will define a method within our class, and we can use the self.metrics that is available as part of this class, right? And how this will be used as part of the llama utils library. So let's say we have this method run chat interface method, right, where we will do the actual inference. So in that place, we can, let's say once the tokens are generated, we can call these metrics ourselves. So for example, self.metrics.log prompt of prompt tokens. So within the model, around the model where the inference is happening, where we are collecting the generation tokens and all, we can call these methods to register these values, right? So this is how, and we can also have other methods like log response, which are some of the custom methods that we have implemented in our custom Llama LLM metrics updated metrics file, which is also available as part of this notebook, right? So this is how you will register the custom metrics. Now, apart from this, as kind of a utility reasons, if you want to use the metrics available as part of the Llama framework itself, for that also we have a way, and so that's what we are calling it as native timings, right? So here, so to get these metrics, actually what you have to do is when you are building the base, when you are building this particular Docker, with this particular base image, or your own base images where the Llama is compiled with the GPU and with the Python support, we have added this small trick where you will basically use the results that you get from the Llama CPP Python framework and make it available as part of your custom metrics. So for this, you need to add these lines, these particular lines to your Docker file when you're building it. Basically, how it is used is, so we have this method self.model inference that is getting exposed, right? And when you do get timings on it, you will get all the timings that you have defined as part of this, as part of this method, the structure to tick and all we are defining here, right? So it will be available to you in the nice and quick, useful metrics from the native Llama framework itself. So we can also use those timings and register a different kind of metrics like LLM inference duration seconds, because it is possible that if the native timings are available in the framework, we can use it as part of this custom metrics as well, instead of we implementing different kinds of metrics again and maybe making some mistakes. So this we can use the native timings here. So so that's pretty much it, and you guys can refer the notebooks that I have shared, right? Let me show we have the metric system notebook. So in this, you can see the AIOS Llama CPP SDK. Here we have shared the updated metrics, which I was talking about. And also in the library.py, you can see how these metrics are used as well. And we also have attached a sample main.py code, which is nothing but the model's inference code to showcase how to, do these, how to call these metrics and how to, instantiate these metrics. So basically, whatever we have discussed here, it will be available in that file as well for your reference. And so yeah, that's pretty much. So the basic thing is we need to have this custom metrics, and we need to use the AIOS instance SDK, and with that, and also we can update the library accordingly. And with all this in place, we can keep the main.py, the inference code, to use the updated metrics. All right. So I really encourage you guys to explore more metrics. Even in the live metrics, you guys see, you can see that we have something called queue length and all. Basically, it says what is the number of tasks that are still present in the queue, and what is the total number of tasks processed, right, in the last 15 minutes or 1 minute, 5 minute averages. And each of the inference code, they have certain functions like on data, on pre-process and all. So what are their FPS, right? So if the implementation is slowing down because of some poor implementation in non-data, so that that can be visible in these metrics. Similarly, LLM related, we have the time to first token and tokens per second rolling average also we have, and similarly time per output token also we have, and total tokens, tokens generated in total tokens per second, and you can use these kind of metrics to come up with your own monitoring mechanisms to understand the stability of the block, or to perform more better load balancing, or better decisions on orchestrating or distributing the load of the models and all. Right? Thank you.